Hello everyone, and welcome to the first of 3 videos that I am making on sketching of polar curves. So you get some very beautiful curves and shapes when you start exploring what polar graphs look like. And we're going to work through these steadily so that you can see exactly how they work and start recognizing patterns. What I want you to try and do is, like you would know, let's say, for example, standard graphs, you know what y equals x squared looks like, you know what y equals mod x looks like, you know what a cubic, etc., or root x will look like. It's useful to memorize and just remember what each type of equation is going to give you when you look at a polar equation. And if you forget, well, then it's very simple. You just go and draw a table of values and you work from there. So table of values for theta and for r. The other point I want to make is that in FP2, we only look at values where theta r is greater or equal to 0. And this is more applicable to when we look at in the next video. But I just want you to keep that in mind. I will mention that again then. Okay, so let's get going. The first type of equation I have is when theta is equal to some fixed angle alpha. And you might recall from loci of complex numbers, we also looked at something where we sketched the argument of z equal to that fixed value. And that gave us a half line. And I have the same thing happening here. If theta is equal to a fixed value of alpha, so for example, let's look at theta equals to pi by 4, well then I'm going to start here always at what we call the pole. And this is my initial line, as I mentioned in the previous video, and I'm measuring anti-clockwise. So I'm measuring pi by 4 anti-clockwise, and this is going to be my half line. And so you just measure that there, and this is quite a simple one. The second equations we'll look at is I actually end up getting a spiral. So if we think about this, r equals k theta, this means that the radius is equal to some constant multiplied by the angle. So as the angle increases, as theta gets bigger, obviously my radius is going to get bigger. And I end up getting something that looks, so I start out here, and it just spirals, gets a little bit bigger each time. Okay. And obviously this isn't drawn to scale, but I have done this. So I started here, 0 to pi, it's 2 pi, sorry, there. Obviously this is my pi by 2 line, that's pi, and that's 3 pi by 2, and that's 2 pi. So each time as I continue another 2 pi radians, I get another section of the spiral, and so I continue. Okay, so this is r equals k theta. Right, moving on. 3 different types of circle equations. First one, very simple. Again, similar to loci of complex numbers. Modulus of z equals some constant, let's say 3. Then you know you're just going to get the equation of a circle. And it's the same here. If r is equal to 3, well then I start there and I'll end up with a circle like this, starting at 0, and this is obviously my value of r. So that one's nice and simple. I then get two other equations, r equals a sine theta and r equals a cos theta. Now, it's useful at this point to just distinguish between sine and cosine. And remember, I'm not going into depth here. We're going to work on this in the lesson as well. But I just want to point out to you that you'll come across more graphs with sine and cosine. And there's two distinct differences when it comes to symmetry. So for sine, I'm always going to have symmetry around the pi by 2 axes. Okay, because I'm trying to show you patterns here so that you can memorize the standard shapes of these curves, which makes it easier, it will make you a bit more fluent and quicker in the exam in trying to figure this out. We don't always want to have to set up a table of values. When we get to cosine, I'm going to have my symmetry about the initial line. So around theta equals 0 axes. I mean, we could have set up a table of values. Maybe it's useful to do this initially. Let's pick some values for theta and see what we get for r. So if theta is 0, then obviously sine of 0 is, just going to sketch this down here. Sine of 0 is 0. So I'm going to start there. Let's look at when theta is equal to pi by 2. When theta is pi by 2, then sine of pi by 2 is 1. And anything in between here, in our case, it will be 1a. Right, so I'll get a. Anything in between, if you want to have a look at sine of pi by 4, I know is 1 over root 2, and so I will have 1 over root 2a. So that means the length of the radius is 1 over root 2a. So I end up getting this as I go along to pi by 2. There we go, this is my pi by 2 axis. I will get to a. Then my next value is at pi, and at pi I am back at 0, so I'll get a value of 0. So as I continue, I will come back down to there, and it continues. I go down to, I'll still have a radius of 1a, and then coming back after 2 pi, I will be back at 0. And so you can see here that sine of theta has symmetry, and I get a circular shape, a circle that has symmetry about the pi by 2 axes. And we can do the same for cosine, a cos theta. The difference in this case is that when theta is 0, well, then r is equal to 1, and so I will start at a. When theta is pi by 2, I am going to end up at 0. So this happens. I go all the way around to 0. And then I go to 3 pi by 2. So I'll have a radius then of length 1. And then the loop continues. And so r equals a cos theta looks like that, with symmetry around the theta equals 0 axis, also known as the initial line. Okay, so those are the three circles I wanted to show you. Okay, the final example, we're looking at r equals a sec theta. And in this case, we can actually use our Cartesian equivalence. Remember, x is equal to r cos theta and y is equal to r sine theta. And we can use this information in order to help us, visualize what this will look like. So I know that r can also be rewritten as a over cos theta, and therefore I can say that r cos theta is equal to a. And I know that r cos theta is just x, and therefore I end up with the equation x is equal to a, which is just going to be this straight line here. And that's how we would think about dealing with the equation r equals a sec theta. Okay, I hope that was useful. In the next video, we will look at something called limecons. That's it.